Hey, 7th period. I wanted to make a video just in case we didn't get to everything from our one-step equations and inequalities notes. I know last Friday I had to run out and take care of something, and Mr. Rose hung out with you while you did your quiz. So we're a little bit behind the rest of the classes. So just in case we don't get to everything today, I wanted to make this video for you so that you could update your notes for one-step equation and inequalities. Remember that I gave you two options. You could have a hard copy and just take notes like regular, like you would do if you were in the classroom with me, or I gave the virtual copy, which should be saved at this point to your drive. So you can either get to it two ways. You can go to your recents, and hopefully that's where it would be, okay? You can go to your search bar and type in Unit 1, rational number operations and inequalities, and it should come up there. If it doesn't come up in either of those two places, though, I encourage you to try to search through your drive to find it. What you can also do to make your life a little bit easier is, right-click on your actual notebook once you find it. And then if you go to this button right here that says Add to Start, and we've talked about this before, so you might already have this done. Add to Start. Then it'll star this for you, and you can go to, on the left-hand side right here on my screen, you can go to Start, and that's where your notebook will always be. I'm going to get a little bit of feedback from you guys about your notebook and how you want to do the next unit, if you prefer digital or if you just want to go to hard copy all the way. I just wanted to try the digital just because I'd never done it before and just to kind of see how it went. So I'll get some feedback from you guys about that before we move on. But for today, so my notes are open in a different window, so let me get there. So we are moving on to equations and inequalities, okay? And this first page just lists all of the, just the standards. So this is a lot of like teacher speak, but it's important for us to understand what we're working on. So you are applying mathematical process standards to use one variable equations and inequalities to represent situations. The student is expected to represent solutions for one variable, two-step equations and inequalities, and on number lines. So last year you did one step. This year we're doing two-step. 7.11a is to model and solve one variable, two-step equations and inequalities. And then the second part of that, 7.11b, is said to determine if the given values make one variable, one-step equation and inequalities true. So that's saying they might give you your variable and have you plug your variable back into the problem. So we'll talk about a couple of those too. But for now, we are just reviewing what you either learned in your 5th APA class or in the Summer Bridge program, because this is 6th grade content. So remember at any time, guys, if I am talking too fast for you, you can definitely pause my video and then add your text boxes and type. Don't feel like you have to keep up with me the entire time. The program that I'm using gives me a 15-minute window to record, so I want to make sure that I don't go over that time. So if you need to at any point, you can always pause me. So solving one-step equations. In order to solve an equation, we must isolate the variable and keep each side of the equation balanced. Okay, and we're going to talk about this a little bit more in class, but the variable is the letter in the problem. Usually you'll see an X, it could be a G, it could be an L, but we're trying to isolate that L and get it by itself, okay? The letter needs to get by itself. All right, guys, somebody was at my door. Okay, so like I was saying, the goal of an equation is to get the variable by itself, or another word for that is to isolate it. And we want to keep both sides of the equation balanced. Remember, the equation has an equal sign, which tells us that on both sides of that equal sign, that it's going to be the same number. It's going to be equal, okay? You can kind of equate that to the balance that you used to have in like primary classes where you put the little teddy bears in and you watch the little thing to see which one, how many teddy bears you could add on both sides in order for the sides to be equal. They were balanced. We can use inverse operations to move terms from one side of the equation to the other. Okay, so inverse operations are the opposite, or they can also be called undoing operations. If you were being mathematically vocabulary correct, you would say the inverse operation. But sometimes you will hear us say the opposite as well. So if we talk about inverse operations, remember that subtraction is the opposite of addition. Addition is the opposite of subtraction. Division is the opposite of multiplication, and multiplication is the opposite of division. Those are our inverse operations. We undo equations by doing the inverse of an operation. Okay? This next bottom part, I'm going to give you the correct answers, and I hope that you can see the 44. It's over my face right now, but I'm hoping that that'll come out. If not, number 6 is going to be x equals 44. We're going to go over these in class, and I'm going to do like a step-by-step process. But for your notes, and if you just want to do the answers for this, those are on there for you. So that is equations, solving one-step equations, okay? And then we move on to the next page, which is one-step equations can also include fractions and decimals. So this is where we solve some equations with rational numbers. And again, we're going to do a couple of these together in class, so I'm not going to spend much time, and I'll go through the whole process with you in class. But I want you to be able to get the correct answers if you didn't get those in class today. So those are going to be the correct answers for 7 through 12. And like I said, at any time, if you need to pause so you can write everything down, please do that. Okay. Moving on. So the next thing that we're going to talk about today is the inequalities. So an equation uses an equal sign to show that both sides are equivalent. An inequality shows that both sides are not equal. So an inequality is going to have one of the symbols that you see down below. So it could be greater than or equal to, less than or equal to, or not equal. Okay, let me show you where I found a couple of these symbols. So the greater than, less than symbol, it should be very easy for you to make. That's already on your keyboard if you were doing this digitally. What I had to go back and do, though, for the greater than or equal to, is to go to this tool right here, this line. And if you click this, you can make your own. Oh, I don't want to move the whole thing. You can make your own, hopefully. There it goes. You can make your own line that will let you actually draw. Insert line. Try to do it this way, and it'll let you draw one right underneath that greater than sign. Okay, and then you can make it darker by going to this one right here where it says line weight, and then you can adjust it so it'll get a little bit thicker if you want it to. So that's how I made the equal to sign underneath the greater than, less than sign. Sorry that took forever to show you. Okay. So we have greater than or equal to, less than or equal to, and not equal. And we have that because in an inequality, there's an infinite number of solutions. So that'll make more sense as we go through these slides at the bottom. But just so you can remember that, an equal sign, an equation has one answer, but an inequality has lots of different possibilities for its answer. So the next part of this is to use an inequality symbol to create a true statement. So this one would read, A, 4 is less than 9. B would read, 5/10 is greater than 45/100. C, -3 is less than -2. And D, -6 and 1/10 is equal to -6 and 10/100. Because remember, I could add a 0 on this side too, and it would look exactly like this one. E, 12 and 4/10 is greater than 12 and 4/100. Okay, so this is something that should be very familiar to you. You've been doing this since probably about first grade when you compared numbers. Okay, Now, sometimes they'll ask for us to write a verbal description to represent an inequality. So I would read the very first one as 6 is less than or equal to x. So when I wrote that out verbally, I would write 6 is less than or equal to x. But if that's true, then a lot of times people will tell you to make sure that your variable is on the left side of your inequality. And if you wanted to write it that way, it would be x is greater than or equal to 6. So it's the inverse. We've talked about, inverse operations. This is the inverse. So 6 is less than or equal to x, and x is greater than or equal to 6. Okay, let's look at the next one. So it says y is less than, so I wrote 1/2. You could write 5/10 also. Y is less than 1/2, and 1/2 is greater than y. Okay? Y is less than 1/2, so that must also mean that 1/2 is greater than y. The next part of it, use the variable as the starting point when reading inequalities. Okay? So you want to start with the letter, the variable. All right. Inequalities can also be graphed on the number line. So in an inequality, if you see a closed circle, it means that number that the closed circle is on is included in the solution. If you have an open circle, it is not included. Okay, and again, I did it down here also. I made this with just a less than symbol, and then I inserted a line underneath it in order to get that or equal to. So that's where that comes from. Go to line, and then you can just draw it right underneath that sign. Okay? All right, let's go back. Let's go back and look at x is less than or equal to 5. Okay? So because it has the or equal to, 5 gets that closed circle. Okay? So 5 gets a closed circle because 5 is included in the solution to this inequality. And so is everything that is less than 5. So 4, 0, -3, any number that is less than 5 will be a solution to that inequality. That's what that number line represents. That arrow would keep going and going and going in that left direction. All right, I am already at 13 minutes because I talked too much. I'm sorry, guys. All right, so for this last part of it, k is greater than 11. Because it has greater than, this is an open circle, and anything to the right would be a part of the solution to this inequality. Anything that is greater than 11. All right, number 11. 12 is greater than or equal to f. If we rewrote this, it would be f is less than or equal to 12. So 12 gets a closed circle because it's included in the solution, and then everything that's less than 12 is included in my solution, in the possibilities for my solution. Okay, so for number 12, D is less than 6. It gets an open circle on the 6, and everything to the left of 6 would complete this inequality. Anything less than 6. All right, 13. C is less than 25. So 25 gets that open circle. It's not included, and anything to the left of 25 that is smaller than 25 is included as a solution to this inequality. 14. 0 is less than or equal to B. So you could also write B is greater than or equal to 0. So 0 gets that closed circle because 0 is included in the solution, and everything to the right of 0 is included. And the last one, let me scroll up a little bit to make sure you can see it over my face being in the camera. Okay, x is greater than or equal to 4.5. So 4.5 gets that closed circle, and it goes